Hello again, everybody. Back in the lab, and today I'm going to do some serial dilations and get those ready for some projects. Everything today will be done sterilely. Got the hemocytometers rinsed off with soap and water, centrifuge tube holder. Everything else we'll go through and wipe down with alcohol. Usually I'd already have the hoods turned on. I'm going to have to do a voiceover for this. Maybe you can even see how loud the hoods actually are. I really like these microfiber towels. They don't leave lint on anything. I also like the shower caps because they are like, plastic fabric or whatever. They can be wiped off with ISO too. I just cleaned myself up with soap and water. We can go ahead and start wiping some stuff down. Also, give everything a really good spray. Get some on his left arms. Now we got our centrifuge tube holder. Got our tween 20 solution. I think I said in the other video it was a 1 to 5 mix. It's actually a 1 drop or even a half drop to 5 milliliters, I believe. I can provide a link for that also. Gotta have a little stand to keep everything in the flow. Couple little tools that'll help us get the centrifuge tube holders out and whatnot. We have sterilized water, which actually I probably will not use. It's kind of just in case I decide to use it. Our sterilized centrifuge tubes. And really, I'm probably going to have to give everything another little wipe. Just getting things roughly cleaned up. Brand new pack of microscope slides, which will be kept sterile after opening in a Ziploc. Only handled in front of the flow. We have syringes. I like the drop size of syringes. We aren't plating anything yet. We're simply doing dilutions. We'll use micropipettes for plating. I'm going to try to keep notes as we go along. I'm going to share the dilution rates. I have paper and a pen, not on the camera, so hopefully I can edit in some of the process, or hopefully even just seeing this kind of helps somebody. Okay. Workspace has a rough cleanup on it. We do need our specimens. have some spores to work with. So, we're going to go ahead and jump on right into this. And, yeah, you know, if anybody has any questions about how to do this, just go ahead and message me. I'd be happy to help. Really think this will be important to a lot of people in the future. And, you know, I kind of wish there was just a video on it a little bit. And I have the microscope camera all set up, so you'll just be able to see. And wish there was a way for me to highlight the spores during the video. Who knows, maybe there is. Not really much of a video editing guy, but let's do it. You hear how loud these flow hoods are? Dilutions. I decided to use pre-sterilized syringes for this experiment just because I was going to use these single spore isolations for projects and I wanted to ensure they were as clean as possible. I did have some sterile syringes at the time, but I wasn't absolutely certain they were free of debris. I didn't want any even sterile debris to mess with my visualizations of the specimens. Taking the first sample. Must have forgot something I needed. Oh, a little shaker, vortex mixer. So I added a sample to the solution, mixed it up. We're gonna add that to the specimen slide and take our original solution spore count. I still apologize for how dirty my microscope lenses are. I haven't really cleaned them appropriately since I got it. I found that under higher magnifications, when you allow more light to pass through, they become less noticeable. Got the cell counter out to kind of help with this. So the spores we're seeing here are a type of oyster spore. They're very, very small. Makes them very difficult to observe in the videos. I think later on in this video we use some spores that are a little more easily viewable. So here we have me calculating the original count off of the hemo. I think it was an average of 75. You could go back and slow these videos down if you were really interested in what the specific numbers were, although this video is primarily just to show you the techniques and a quick little walkthrough of how the procedures ran down, not necessarily the specifications of the project I'm doing beyond, if you've seen the other videos, my recommendations for dilution math and for using a micropipette. So now we are looking, after the second dilution we diluted it, so it would be much closer to an average of 1 per square. I think that, actually, I just recalling right now, I think that the original count was actually 7.5 average, so we would have, say you had 7 spores for every drop and you needed 1 per drop, you would add 1 drop to 6 other drops, so there would be 7 drops between those 7 drops. That is just very vague, rough conceptual math for your dilutions. You would have to do a little more adding and multiplication to figure out your actual dilution, but that is more so of a metaphorical example. Okay, so we've diluted our average down to about 5 spores per square, so we would dilute 1 to 4. It's a good example. In this video, I'm actually preparing 4 different specimens for single spore isolation. I believe we'll be throwing another oyster specimen on next. It's been a couple weeks since I've recorded this video, and now that I'm doing the voiceover, these videos are what I would say are relatively boring, but I felt it would be a good idea to have people kind of see what goes into these process. Again, I'm going around checking the slide for contaminations. Yeah, and I started to count that one up really quickly. It's actually hard to see in the video because these oyster spores are nearly invisible and actually smaller than any other spores I've worked with, next to maybe lion's mane. I think the lion's mane are actually just a hair bigger than the oyster spores, and they're a little bit easier to tell because they are perfectly round and almost catch a greener hue to them under the microscope compared to the oyster spores, which are smaller and nearly translucent completely. So we went ahead and did our first estimate on the second specimen, and then I think that we're about to measure our second dilution. Oh, no, we've gone to the third specimen. We are looking at the third specimen now. Last round must have gone pretty easily. What I've actually done here too is I will shoot below the dilutions. If it looks like my rate is going to be below 1 average, that's completely fine, because as long as it's below 1, what we have is a higher likelihood of non-coupled spores being plated. We have a higher likelihood of completely missing a inoculation point with a if you're measuring out your spore solution so they are relative to your pipette size to a drop, and your average is below 1 if you are measuring relative to your smallest micropipette distribution amount, then the likelihood is appropriate. And as you go through plating, you may have primarily inoculation points that do include just one spore, along with more that have less than one, so 0, because you couldn't have a partial spore. But then you have decreased your likelihood of inoculations that contain more than one spore, which is really what we want. I am sorry again for how boring these videos are. The hemocytometer process is very, very simple. I think that the visualization of the whole process just makes it that much easier. So here again, we're counting our initial average before it gets diluted. Just going through and counting every square of the 16 squares. Here it looks as though we have a 6.5 average. So what we're going to do is dilute that 1 to 7, and it's going to give us below a 1 average. Really as simple as that for me. Some people might say you really want to be precise. In my case, I felt like if I was able to obtain even just a few monokaryons, it was a success. This whole process and specifically what I'm using it for and why you would use single spore isolations can get very complex, so we aren't even going to get into that right now. Why you would want a monokaryotic culture, we can try to cover that in another video. Really, there's a myriad of reasons, but primarily from what I've gathered, you would want to isolate monokaryons for interspecific crosses. Or say if you wanted to prevent back crossing while breeding two parents to a certain extent. Downfall of spore isolation is that you don't know what traits your spore is carrying from the parents. I think in real time, this entire procedure took me about 2 hours to go through and measure 4 different specimens twice on the hemo and do all the dilution. It's really not that bad. And this obviously doesn't include plating. Plating is another video. It is available. And if I remember correctly, this last specimen may have been almost perfect. I realized that if you can add almost the smallest sample you can to, say, your centrifuge tube, I think I was doing 1 milliliter to the smallest sample I possibly could take off of spore print, nearly just rubbing the tip along the foil and introducing it to the centrifuge tube. And I'm pretty sure that what we're watching here, doing that got me just about spot on, luckily, of course, in this case, to the dilution ratio that I was seeking. And obviously that'll all be variabilized on what you are seeking. I think during one of these, maybe even the last one, there was a big old air bubble in one of the, I think it was the bottom right corner, so it just made that section nearly uncountable. What I did in that case is I just counted the center section. Yep, I averaged 8. I think what I did here too, just to verify that it was such a low count, is I filled up both sides on the hemocytometer and counted that. So I counted 8 total squares with a total of 8 spores, divided that by 8, and it had me right where I wanted to be, surprisingly, which was great. It was a good way to finish off the session. I'm gonna go ahead and label and bag everything up. Let's save those for plating. Hopefully I can edit that up appropriately and turn it into something. Went through and did 4 dilutions there. I don't know if anybody might have noticed, but I could point out that the dilutions got closer and closer with the original solution as we progressed. I mean, you'll get an idea of how much sample to add to the original water amount as you kind of get a feel for what's going on. The last solution I made, I mean, it was like dead on. It was kind of interesting. I chose to count 8 squares. In that case, I filled up both the sections on the hemo and did an average between 8 squares. One of the sections had a bundle of spores, so I decided to replace the bottom corner with the middle section and counted that one instead. But I still counted 8 sections on both of the areas of the hemocytometer, so I took my average from those 8 cells, and it was only 8 spores, so I mean it really gave me about 1 spore per section, and essentially works out to 1 spore per 1/10 of a microliter, or 10,000 spores per milliliter. I didn't get very much solution on that. I figured I was going to have to water it down, so I only got like 1/10 of a milliliter on that, but that should really be more than enough for plating out potential monokaryotes with the 1/10 of a microliter pipette. Even just with 1/10 of a milliliter, that would be about at least 100 drops. I don't know. I can't do that off the top of my head. We'll get that all figured out. That's pretty much the dilution process for me. Next step will be plating them and get back in here for that. Alrighty. Good day.